Hi everyone, in this video we are going to again continue solving quadratics. So this time we have a new method called completing the square. We are going to use completing the square to force a trinomial to be a perfect square trinomial. The reason we're going to do that is because then we can factor it and then use the square root method to finish up the solving for our quadratic equation. So let's look at how we can manipulate a quadratic to be a perfect square. The first thing that you're going to do to complete the square is move the constant term, that is the c value, over to the other side. So you have the x's on one side and the constant on the other. Now when I subtract 1 from both sides to get x squared minus 10x is equal to negative 1, notice that I left space here. I'm going to leave space on both sides because I'm about to fill in that blank with my completed perfect square trinomial. So the next thing we need to do is we're going to calculate a new c value, and that's what you're going to write in that blank there. There is a formula here that you're going to use to find the new c value. You take your b, that's negative 10, you divide it by 2, and then whatever that quantity is, you square it. And that's going to be our new c. So negative 10 divided by 2 is negative 5, and then negative 5 squared is 25. So we are going to add 25 to both sides, putting it in both of these blanks. That's x squared minus 10x plus 25 is equal to negative 1 plus 25. Again, filling in both of those blanks. The left-hand side now we are going to rewrite as a perfect square trinomial. That means we are factoring it. When you factor a perfect square trinomial, the first value is the same. The base of the perfect number, 5, goes on the right, and then if this is a negative 10, that means it's going to be a minus inside. So we have the quantity x minus 5 squared. On the right-hand side, I do need to simplify this. 25 minus 1 is 24. Now from here, I can use the square root method, meaning you are going to take the square root of both sides and then continue simplifying from there. So I'm taking the square root of both sides. That leaves me with x minus 5 is equal to plus or minus the square root of 24. So let's simplify the square root of 24 first. I'm going to leave everything else exactly the same. 24 is 4 times 6, so that means I have plus or minus 2 square roots of 6, and then I need to add 5 to both sides. So I have x is equal to 5 plus or minus 2 square roots of 6. And that's my final answer there because I've simplified the radical as much as I can and I've solved for x. Let's look at another example, but this time the completing the square is something we're going to do when a is not equal to 1. So notice that out front here you have this 3. So whenever you have a trinomial with a not equal to 1 and you want to factor it, you can force it to be a perfect square trinomial and use the completing the square method. Now in order to do this, you are going to factor out whatever that coefficient is. So we're looking for a GCF here. So looking at this problem, the GCF of this trinomial is 3. So we're going to factor out that 3. That leaves us with x squared minus 12x plus 50. From there, we can multiply by 1/3 on both sides because that 1/3 will divide out that 3. That leaves me with x squared minus 12x plus 50, and 0 times anything is just 0. So I've changed this so that I have the a value to be 1 now. I've changed that by factoring out the GCF and then multiplying by the reciprocal to remove that GCF from my equation. Okay, so now we need to use the completing the square method on this. So the first step is to move the coefficient, the c constant term, over to the other side. So I'm subtracting 50 from both sides. And now I'm going to fill in that blank with a better choice, a squared choice. So I'm going to find that c value by doing b divided by 2 squared, which means I've got negative 12 divided by 2 squared. Negative 12 divided by 2 is negative 6, and negative 6 squared is 36. So I'm going to put a positive 36 in both of those blanks. Okay, so factoring this perfect square now, I've got x minus 6 quantity squared is equal to, and then negative 50 plus 36 is negative 14. From here, I use the square root method. So I'm going to take the square root of both sides. That gives me x minus 6 is equal to the square root of negative, plus or minus the square root of negative 14. Now I do need to simplify this radical. So let's simplify. 14 is 7 times 2, but there's this negative inside that I need to pull out. Remember, the square root of negative 1 is I. So I've got plus or minus the square root of 14 times I. Okay, so now let's move the 6 over. X is equal to 6 plus or minus the square root of 14 times I. And that is our fully simplified answer. So we have completed the square and used it to solve for x. The other thing that I want to show you today is using completing the square to help you with graphing. If you have a quadratic equation that's in standard form, we can change it into vertex form by using completing the square. So in order to do this, the process is going to be quite similar to what we were just doing. This c value we are going to move over to the other side. Now on the other side there's a y, so when we subtract 22 from both sides, that's going to be y minus 22 is equal to, and then we have our x squared plus 18x and our new blank. Now this blank we're going to have on both sides. We have to add whatever the c value is to both sides. So let's find that c value. b divided by 2 quantity squared. b is 18, so we're doing 18 divided by 2 squared. That's 9 squared, which is 81. So we're adding 81 to both the left and to the right. That means we have y plus 59 is equal to, and then this quantity I'm going to write as a perfect square. So that's going to be x plus 9 quantity squared. And then if I want to get it in vertex form, which is this form up here, notice what you have. The a value is 1, you have x minus h, you have the square, we just need this k value out here, and that's this 59. Let's subtract the 59 back over to the other side, and that gives us our vertex form. X plus 9 quantity squared minus 59. This is much, much easier to graph than going through the finding the axis of symmetry and the y values and the pattern and all that kind of stuff. So 9, negative 59 is going to be down here somewhere, and then we can follow just the parent function's pattern to get that U shape for our parabola. All right, oops, sorry, I just made a mistake. Did you catch it? What was the mistake that I made with graphing vertex form? That's a positive 9, which means my vertex is going to be negative 9, negative 59. That was a close one. All right, let's erase that graph and let's go negative 9, negative 59, which puts our vertex down there somewhere. And then we can use the pattern to give a rough sketch there. All right, so now there are a few things that you should be able to do. You can manipulate a trinomial to make it a perfect square. You can factor the perfect square trinomial, and then you can use the square root method to finish solving it. Why don't you try the two problems down at the bottom of the page now?